Hello guys, welcome to the new video again. Uh, in this video, we will start with a new topic in permutation and combinations. Let's discuss some basic questions to understand what's going on. So this is the question here. We start with this question. How many pairs if set A and B are there that satisfy the condition? So I think we done this in previous lectures. So no. So we will start with new topic here only. What is going on? Yes. All right. So next topic is permutations with limited repetition. Limited repetition. Right. So when we allow only countable number of repetitions for a element of set, so how will we calculate the permutations from that set? All right. So so when we say set, let's say this is a set which has three elements A, B, and C. But in this, there is no repetition, right? But if we allow repetition here, then let's say limited. If we allow, let's say limited repetition, all right? So we can say from the set A can repeat two times only, and B can repeat three times, and C can repeat only one time. All right. So how can we can say how can we represent it as a set? So let's say S dash is the set where A can repeat two times, and B can repeat uh, three times, and C can repeat only one time. So it has how many elements? Two, three, five, and six. Six elements. All right. S dash is six. All right. So how many we can say how many three-letter words we can so now question is how many three-letter words we can how many three-letter words we can create from the set S dash. All right. So what is so here is the formula for this. Formula is, let's say the S dash has size n. All right. So n, which is n1 elements, we can say uh, let a repeat itself repeats n one times, b repeats n two times, and c repeats n three times. So if we want to create some combinations of three-letter words, then how can we calculate this? It would be like 3 factorial upon is 6 factorial. What is going on? How many three-letter words are possible from this multiset? Right. Upon 2 factorial. Right. So this is what I was saying to you. Let's say n factorial. So n factorial upon n1 factorial, n2 factorial, n3 factorial. But the condition is here. Condition here is that if uh, there are n x distinct letters in the set, then we create uh, words of size n x we say x. But this is not the case always. Many jumble words from so in this see. So if the multiset is of size n, permutation with limited repetition is equal to n factorial upon n1 factorial n2 factorial dot where n1 n2 times elements repeats themselves inside in the multiset. Right? This is how we do. And some question we will discuss here for this. So, are you ready? So let's see what is going on. 8 minutes ago. So, next question is how many jumbled words from, this is a very important formula here, Mississippi, Mississippi. This is a very important word. So how can how many jumbled word of size? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Size is 11 here. So what is this? Let's say this is a multiset which contain uh, I 4 times, right? P 2 times and M 1 time and S 4 times. right? Um, how many number we can factorial 2, 4 factorial, 2 factorial, and 4 factorial. This is the answer. Next question we can modify here only is jumble word for equation. So what is jumble word for equation will be like equation. All are different, so it would be 8 factorial upon everything repeats itself one time, so it would be 8 factorial only. Right. Next question is little bit modification in Mississippi only. So let's see what is the modification. The question. So modification is uh, how many jumble word from Mississippi, but without not what is this saying? Oh, right. This is on, I think. Not starting with P. Not starting with P only. All right. So what we can do is starting with P, we can calculate starting with P. Then starting with P always will be like, let's say this is fixed here, one P is fixed here. So it would be like starting with P will how many words are there? 10, 10 factorial upon 4 factorial and 4 factorial because one P is now there. And total is 11 factorial upon 4 factorial, 4 factorial upon 2 factorial. This is the answer. But starting with M be like 10 factorial upon 4 factorial. Wait a second. लोअर टी शर्ट में दूंगी right. This is like that and question we can or second method would be like starting with M. And 10 factorial 11 places only and we have 10 places left, right? And 4 factorial, 4 factorial and 2 factorial. Starting with S would be like 10 factorial upon 4 factorial, 3 factorial and 2 factorial. And starting with I will like 10 factorial upon 4 factorial, 2 factorial, A plus B plus C. Alright. Right. Next question will be variation in this. It will be four identical math books. Alright. The math book repeats four times. Repeat. And three identical English and two identical physics books. Total arrangement of cell would be 437 to 9 factorial upon 4 factorial, 3 factorial, and 2 factorial. Would be the answer here. If not identical, then if not identical is that if not repeats themselves, then 9 factorial would be the answer. Next question is uh, from Mississippi, a random word is jumble word. So, what is the probability of its start with P? So, combination starting with P would be 10 factorial upon 4 factorial upon 4 factorial and upon total things 4 factorial, 2 factorial, and 4 factorial. This is the probability. 2 by 11 is the answer. So next topic we will discuss six categories of permutation, constraints of permutation. All right. So one is starting with, ending with, not starting with, and sometimes thing. So thank you so much for watching this video. We will meet you in the next.